Over the last few years, we have all seen the evolution of AI. We have moved from generating text and images to complex, multi-step reasoning tasks. Models have evolved to keep up with the changing demands, and the infrastructure needs to evolve as well. Recognizing that the infrastructure requirements for pre-training, post-training, and real-time serving have radically diverged, I'm thrilled to announce that Google will be launching two 8th generation TPUs, TPU-8T and TPU-8i. These next-gen TPUs will power Google's own AI infrastructure needs to build the best models, like Gemini, and these will also be available for our Google Cloud customers by the end of the year. Model sizes are growing exponentially. The new frontier models will reach trillions of parameters. To build these frontier models of tomorrow, we need infrastructure that can handle mega-scale pre-training without being stalled by data bottlenecks. That is why we built TPU-8T, the large-scale training powerhouse successor to the 7th generation Ironwood. TPU-8T is optimized to reduce training time for trillion-parameter frontier models, delivering a staggering 121 exaflops of native FP4 computes and 2 petabytes of shared HBM within a single 9,600 chip superpod, a 3x increase in peak performance per superpod over the previous generation. With 2x ICI scale-up bandwidth and 4 times raw scale-out BCN bandwidth compared to the previous generation, TPU-8T drastically reduces data bottlenecks. To further accelerate the development of frontier models, we are scaling distributed training beyond a single superpod. Utilizing pathways in conjunction with the JAX development framework, we can now scale to over 1 million TPU chips in a single training cluster. Within the cluster, up to 134,000 chips have non-blocking communication, delivering 1.6 million exaflops with near-linear scaling performance using Virgo, our brand new state-of-the-art networking fabric. To effectively scale data-heavy workloads, we've eliminated the training delays caused by data ingestion bottlenecks. By integrating Managed Lustre, now with an industry-leading 10 terabytes per second of throughput, and TPU Direct, we deliver 10x faster storage bandwidth and direct-to-chip RDMA access. TPU-8T redefines performance capability by moving block scale multiplication directly inside the MXUs, eliminating VPU overhead and enabling higher quality, low-precision flops through native in-MXU quantization. By supporting smaller block sizes, TPU-8T maintains superior model quality while staying perfectly balanced across all arithmetic and network intensities. This architectural harmony minimizes exposed vector ops time through balanced VPU scaling and finer-grained offloads to secondary threads. Ultimately, by unburdening the primary tensor core and easing pressure on collective communication overlap, TPU-8T allows for more flexible partitioning strategies that push the absolute limits of model flops utilization at massive scale. Whether you're training a multi-trillion parameter model or performing bulk inference, TPU-8T provides the raw arithmetic density and bisection bandwidth needed to push the boundaries of AI pre-training. As we enter the agentic era, the industry is hitting what we call the latency wall, where traditional architectures struggle with the real-time demands of autoregressive decoding and complex chain-of-thought reasoning models. That is why, alongside TPU-8T, I am also thrilled to announce a second 8th gen TPU that directly addresses this issue. TPU-8i is our specialized post-training and inference engine. While it remains highly capable of training any state-of-the-art frontier model, we are optimizing its core features to be the best reinforcement learning and serving infrastructure for the next generation of reasoning models. A defining breakthrough for TPU-8i lies in its ICI networking architecture, which pioneers the board-fly topology for TPUs. Moving beyond our standard 3D torus mesh, this hierarchical board-fly design maintains a compact network diameter to reduce tail latency for the complex all-to-all collective communications that drive the next generation of mixture of experts models. By shortening the network diameter needed for all-to-all communication, the very heartbeat of MOE and reasoning models, BoardFly achieves up to a 50% improvement in latency for communication-intensive workloads. TPU-8i also breaks the memory wall with 3x more on-chip SRAM over the previous generation to host a larger KV cache entirely on silicon, significantly reducing the idle time of the cores during long context decoding. By integrating a specialized collectives acceleration engine, TPU-8i further reduces the on-chip latency of collectives by 5x. Lower latency per collective operation means less time spent waiting, directly contributing to higher throughput required to run millions of concurrent agents instantly. The result is a system that delivers 80% better performance per dollar for low latency serving compared to previous generations. TPU-8i doesn't just deliver speed, it delivers ultra-low latency and economic efficiency for real-time reasoning at scale.
The pace of innovation is breathtaking, and at Google DeepMind, we're at the very heart of pushing the boundaries of what's possible. But progress in AI isn't just about algorithms and ideas. It's fundamentally also powered by computation. I'm thrilled about the prospects of the incredible progress we will make with TPU-8t and TPU-8i. For over a decade, Google has been on a journey to build the world's most powerful AI accelerators, our tensor processing units, or TPUs. These engines are behind the AI breakthroughs coming out of Google and Google DeepMind. Think of AlphaFold. Running on TPUs, we predicted the 3D structure of nearly all known proteins, a monumental achievement for science recognized by a Nobel Prize. From the early days of AlphaGo mastering complex games to our most advanced Gemini models today, each generation of TPU has allowed us to tackle problems once thought intractable. But the most profound shift happened when AI looked inward. Our colleagues introduced AlphaEvolve, a coding agent designed to discover new mathematical truths. It did what humans couldn't for 56 years, improving on Strassen's algorithm for matrix multiplication in mere days. Even more remarkably, AlphaEvolve began optimizing the lowest levels of hardware powering our AI stacks. It proposed a circuit design so counterintuitive yet efficient that it was integrated directly into the silicon of our 8th generation TPUs. This is the latest example of TPU brains helping design next-generation TPU bodies. Our most advanced models, the Gemini family, were trained and are served on TPUs. The ability to handle multimodality, to reason, and to generate human-quality text, images, and more requires training on vast datasets with unprecedented computational power. TPUs make this feasible. This virtuous cycle has created the foundation for a new kind of workload, Agentic AI. We're moving from models that predict to agents that plan and build systems that solve multi-step problems in physics, biology, and a variety of knowledge worker tasks. We're seeing the birth of automation loops where AI agents formulate hypotheses and run experiments autonomously. This requires more than just raw power. It demands the high-bandwidth, low-latency loops that reinforcement learning and continuous learning require. Through projects like Genie, we're building infinite interactive world models. These allow our agents to practice and refine their reasoning and behavior in diverse simulated environments before they ever act in the real world. For both Google and Google Cloud customers, TPU-8t and TPU-8i represent a fundamental advance in capabilities. These 8th generation TPUs empower us to develop increasingly sophisticated and general-purpose iterations of the Gemini model family, accelerate frontier research in pharmaceutical discovery and climate resilience modeling with unprecedented speed, and unlock the era of autonomous scientific inquiry and real-world physical AI breakthroughs. The horizon of AI is expanding rapidly, and with the raw compute power of TPU-8t and the architectural efficiency of TPU-8i, we are providing the computational foundation for the next wave of innovation across the world. We aren't simply engineering faster processors. We're constructing the bedrock for the agentic era, a world where AI moves beyond assistance to think and act alongside us as a true partner in discovery.
Customers often ask if scale must come at the expense of speed. The reality of our 8th generation TPUs is that we have transitioned away from a singular, one-size-fits-all approach. While both architectures remain highly capable across the full AI lifecycle, encompassing pre-training, reinforcement learning, fine-tuning, and serving, we have purposefully optimized each system to unlock maximum efficiency and value for the most critical stages of AI development.
Exactly. While TPU-8t is the powerhouse for pre-training throughput, and TPU-8i is the specialized engine for real-time inference. Both use the same full-stack co-design approach. TPUs have evolved immensely since TPU v1 in 2013. At that time, we recognized that the increasing computational demands of neural networks, like those for speech recognition, would necessitate the creation of accelerators specially designed for neural net computations. That insight drove the development of this specialized hardware, which is now the bedrock for Google's AI advancements, powering Gemini, Search, Ads, and YouTube. Through cloud TPUs, we bring that same proven-at-scale infrastructure to our GCP customers. For over a decade, our journey has been about building the world's most powerful and efficient AI accelerators. Each generation has unlocked new frontiers, allowing us to tackle challenges once considered intractable.
Couldn't agree more, Jeff. The 8th generation TPU chips are not simple derivatives of one another. Each is a ground-up redesign to specialize for individually demanding serving and training workloads, while still staying true to the TPU architecture and remaining fully integrated with the powerful JAX, PyTorch, XLA, and Pathway's AI hypercomputer software stack. This specialization and ground-up redesign, all in deep collaboration with Google DeepMind, will deliver unrivaled price performance and power efficiency. We can't wait to see what the world will build with the power of TPU 8i.
And TPU 8T,